10 grams of aluminum and 50 grams of bromine give 35.7 grams of aluminum bromide. Find the percent yield of this reaction. The atomic and molar masses are given. This is a problem based on stoichiometry, and so ratio of moles is important. So first find practical ratio of number of moles of the reactants. Two moles aluminum, 3 moles bromine, giving 2 moles aluminum bromide. So the ratio is 2:3:2. This is the theoretical ratio. Now let us go to practical ratio. We'll find the actual moles in the given problem. The number of moles, we would use the formula mass in grams divided by molar mass or atomic mass. Number of moles of aluminum equal to the mass in grams, 10 grams, divided by the atomic mass 27, which is equal to 0.37. In the same way, number of moles of bromine, we get 0.31, and aluminum bromide we get 0.13. Now we would use this information, the number of moles, to find the limiting reactant or the reactant which is fully consumed, and the next one that is not consumed, that is which is in excess. Now the theoretical ratio is 2:3, 2 aluminum plus 3 bromine, giving 2 AlBr3, and actual we have got moles of aluminum as 0.37, then 0.31 and 0.13 moles actual. Now let us find which is in excess, whether this is in excess or this is in excess, and the another one, the opposite one, which is not in excess, is the limiting reagent which is fully consumed. So now, using simple arithmetic, if 2 moles, using this information, they need 3 moles of bromine, in that case 0.37, which is coming from here, will need how many moles of bromine? And the answer is 0.37 divided by 2 into 3, which is equal to 0.55 moles of bromine. So we need Br2 0.55 moles. However, if you go back, we are having only with 0.31 moles of bromine. It means bromine is fully consumed in this case, and as such bromine is our limiting reactant. Why is it essential to find the limiting reactant or non-limiting reactant? It is essential because the one which is in limit, that quantity we are going to use to find the corresponding production of the product. Now in this case, since bromine is the limiting reactant, we will establish the ratio of bromine as to the product, which is aluminum bromide. So we know 3 molecules of 3 moles of bromine, they give 2 moles of aluminum bromide. So the ratio is 3 as to 2. Using this ratio, we will find theoretical yield, theoretical production of aluminum bromide. So the equation goes as, if 3 moles of bromine, they are producing 2 moles of aluminum bromide. In that case, 0.31, which is the actual quantity available with us, would produce how many moles of aluminum bromide? And simple, take this down, take this up, and multiply by this 2. So we get answer 0.31 divided by 3 into 2, that is equal to 0.2 moles of aluminum bromide. So theoretical yield is 0.2 moles, which will convert to grams, that is equal to 0.2 multiplied molar mass of aluminum bromide, which is 266.7, which gives 53.34 grams. So this is theoretical yield in grams. This was in moles, this was in moles, and this is in grams. Now we shall find out the percentage yield by using the formula practical yield multiplied by 100 divided by theoretical yield. Practical yield or actual yield are same. Going back to our original problem, we can see how many grams of aluminum bromide was produced. So as you can see, it is 35.7 grams, which is actual yield. So practical yield is 35.7 into 100 we take for percentage, and we divide this by the theoretical yield, which we just now have calculated, this one, and which is 53.34, and so the answer is this is equal to 66.9%. That is the answer. So to recap, for, for such problems stepwise, first find the number of moles, actual number of moles in the reaction. From that, find the limiting reactant. Help the quantity of the limiting reactant to find the number of moles of product theoretically. That is the theoretical yield in moles. So first we found out the number of moles, then we found out the theoretically number of moles of the product, then using that thing we found the mass in grams theoretical, compared that with the actual mass of the product form, and found out the yield percentage.